Hello everyone, welcome to another video by the YouTube Lab of Everything. Since we couldn't continue motion, I'm gonna continue it in this video. In the previous video we have taken an overlook on motion, so today we will continue and actually start with the chapter. So we'll be starting with motion along a straight line. So what are we waiting for? Let's go ahead. So to begin with, we need a straight line. So motion along a straight line is the simplest type of motion. So we already know it as rectilinear motion, etc. So motion along a straight line. So now let's make different points on the straight line. So let's make this point O, B, A, B, C. A, B, C, D. So these are the 4 points of, let's say, a huge country. Now this is city A. So city A, and next comes city B. Let me extend this a bit. Okay. Next comes city B, and then city C, and city D. Now these are the 4 cities, and let's say a car is traveling from city A to city D. Now there can be many instances we can describe from this motion along a straight line. We can describe the distance, displacement, speed, velocity, acceleration, etc. For now, let's just go on with the distance and displacement. So now let's say an object or a car starts from city A and reaches city D. Then the distance is AD. So the distance would be AD, and the displacement, which is the shortest distance between the starting point and the ending point. I have defined this in the overview. Please check it out. So since AD is the shortest distance between A and D, distance equals the displacement. Now let's say the object travels from A to D and comes back to C. Then the distance would be AD plus DC. So that would be the distance, but the displacement would only be AC, since AC is the shortest distance between A and C. So that's how you could differentiate between distance and displacement. Now let's say the car starts from A, goes to D, and returns back to A. Then the distance would be AD plus AD, but the displacement would be 0, since the shortest distance from A to A is 0. So then the displacement would be 0. So that's how you can differentiate between distance and displacement. This is one of the easiest examples. I have given a different example in my video, which I've mentioned in my video Kinematics, which was my first video. So in that, while I was differentiating between distance and displacement, I have given a better example. So if you want, I can give that right now. I'll just go with it. So now this over here is point A. Over here, this is point A, point B, C, and D. This is the same example I've given in my other video Kinematics. So the object has traveled till D through BC. So the object has traveled from A to B, and then B to C, and then C to D. But the displacement would be AD. Because this is the shortest distance from A to D. I've explained this example in detail in my video Kinematics. I have linked it up in the top right corner in the description below, and I will put it in the end screen, so please do check it out. Now let's talk about uniform and non-uniform motion. So let's say an object is traveling from point A to point B on a straight line. So an object is moving every 1 meter. It takes 1 second to reach point B. So to reach point B, every meter, let's say it's 100 meters, it takes 100 seconds. So every meter it's traveling 1 second. So that means the object is moving in uniform motion. Now let's talk about non-uniform motion. So when an object covers unequal distances in unequal intervals of time, it's called non-uniform motion. I've defined uniform and non-uniform motion in my previous video over the overview of motion. I have linked it in the top right corner and in the description below. I will put it in the end screen also, so stay tuned to watch it. So uniform and non-uniform motion. So we've discussed about uniform motion. Non-uniform motion is when an object covers unequal distances in unequal intervals of time, or the other definitions I have put in the previous video. So let's say the first meter it covers in 1 second. The next meter it covers in 2 seconds. The next meter, the next 1 meter, it covers it again in 1 second. So the object is continuously changing its speed. So that means that the object is traveling in non-uniform motions, because every meter it's changing its time. So yeah, that's non-uniform motion. Another one is, so let's say 2 meters it covers 1 second, and 1 meter it covers 2 seconds, and 3 meters it covers 1 second. So like that, when both of them are unequal or one of them are unequal, it's non-uniform motion. So I will show you how you can show it in a graph towards the end of the video. Then you'll get a clear explanation of uniform and non-uniform motion. So stay tuned to watch it. Now let's discuss about speed and velocity. So let's start with speed. Speed could be defined as distance. Okay, that's wrong. Distance per unit time. So let's say every 1 kilometer it takes 1 hour. So the speed would be kilometer per hour. So that's the speed of an object. So that's the definition of speed. Average speed would be total distance over total time. This triangle symbol you see, it represents total. So like total distance. So you got two distances, 25 and 15, divided by time, which is, let's say, the first 25 kilometers it moves in, let's say, 30 minutes plus 15 minutes. So the average speed would be 25 plus 15, which is 40. I think 40. Yeah, it's 40 plus 45. I mean divided by 45. So when we cancel these out, it's 5. 2 5s, it goes here 8 and here 9. So it would be 8 upon 9 kilometers per hour. So that's the speed of an object. So that's how you can calculate the speed of an object. But what actually is speed? So speed would be the rate of change of motion, or the rate of change of distance. So like, how can you measure motion? That's what you use speed. You can use velocity also, but velocity is speed plus direction. Yeah. So a common example for velocity would be gravity. So let's say 9.3 something, right? 9.3 meters per second in the downward direction. So this is velocity. So that would be speed with direction. So that is velocity. The different objects may take different amounts of time to cover a given distance. Some of them move fast and some of them move slow. The rate at which objects move can be different. So that rate would be speed. So it could be also velocity, but direction must be specified. Velocity could be defined as rate of change of displacement, and the formula would be displacement upon time, and average velocity would be initial velocity plus final velocity divided by 2. That's the average velocity. This is how you represent average velocity. This is how you represent velocity. This is how you represent speed. Okay, that went wrong. This is how you represent distance, and this is displacement. A t is very simple, it's just a t. So yeah, that's how you can represent average velocity. I have talked about speed and velocity in kinematics as well, so I'll just tell out all the topics which I've done in kinematics, because I don't want to repeat it all over again. Even you would get bored. I have done what is motion. I think I have done what is motion. It's been a long time. I have done distance and displacement. I have done speed versus velocity. I have done acceleration. I have done equations of motion. Basically, this entire chapter, but with a different name. So that's what I've done in kinematics. So I'm just kind of repeating, but on a different topic. So yeah, please check that out as well. Now let's talk about acceleration. We can define acceleration as the rate of change of velocity. So uniform acceleration is when velocity changes by equal amounts in equal intervals of time, and the opposite of it would be non-uniform acceleration, which is the velocity when the velocity changes by unequal amounts in unequal intervals of time or equal intervals of time. It's the same thing, it's non-uniform. So during uniform motion of an object along a straight line, the velocity remains constant with time. In this case, the change in velocity of the object for any interval is zero. However, the non-uniform motion velocity varies with time. It has different values at different instances and at different points of path. Thus, the change in velocity of the object during any interval is not zero. So now let's move on to the formula. Acceleration equals change in velocity in time taken. In few textbooks, you can see the formula of acceleration in this way, that acceleration as the change in velocity, something like this, change in velocity upon time, or like this, change in velocity upon time. All these formulas are correct. It all basically means the change in velocity over time. So v is the final velocity, u is the initial velocity, and t is the time taken. So most of the time the initial velocity would be 0, but not all the time. You could get initial velocity as 5 and final velocity as 10. So let's do like a small problem. Let's say the initial velocity was 0 and it accelerated to 5 meters per second. Then in, let's say, this duration was 2 seconds. That's a lot. Then the acceleration would be 5 minus 0 over 2, and that would be 5 upon 2, or yeah, it would be 5 upon 2 or 2.5 meters per second in whatever direction specified. Let's say it's specified north direction. So there you go, problem solved. So that's how you can solve problems based on acceleration. But remember, the initial velocity might not always be 0. It can be, so like I gave you an example, 0 and 5. It could be 5 and 10. So it could be like that. And also one more thing, if the acceleration you got is a positive answer, then the object is accelerating, like increasing its speed. If you got a negative answer, that means the object is decelerating, it's decreasing its speed. So always remember that. So we could be, for a negative answer, you can give like initial velocity was 5 and the final velocity was 0. Then it would be 0 minus 5 upon 2, and that would be minus 5 upon 2, and the answer would be minus 2.5. This is deceleration or retardation. You learn about that in your higher classes. For now, just know this. So thank you for watching. We will continue in the next video because the video has become too long, at least like it became 15 minutes. I'm sure you all would be bored for learning so much. So we will continue about graphical representation of motion, which is distance time graph and velocity time graph, and also about the equations of motion in the next video. So that would be, at least I think I will upload it tomorrow. So stay tuned and watch it. The kinematics and the other video which I've mentioned in the overview of motion, which I've mentioned in this video, should be on your screen right now or will be on your screen soon. So it's also linked in the description below. So make sure you watch it. Thank you. Bye.